Very good afternoon, my dear students. How you all are doing? This is one of the bright afternoon. We are assembled here to learn next segment on work, energy, and power. Okay. Dear students, before I move ahead, I welcome Vinod Pawar. Very good afternoon, Vinod. How you are doing? In fact, this session happens to be the second lesson in work energy power. So, in my previous session, I had solved some 7 or 8 problems, I think so. So, in today's session, I'll be progressing with few more interesting problems on work energy and power. And in today's session, I picked up very interesting problem on bullet and block. Okay, so even that problem also you please watch out. Okay, now let us start off with my brief introduction. My name is Uttam Kumar Umarji. I'm an MTech graduate. I'm a verified physics teacher on Unacademy, and presently I'm holding number 6 position in Karnataka CET. And regarding my experience as such, I've taught physics for JW Advanced, J Main, NEET, etc. for 19 years at Delhi, Kota, Bangalore, and all across the nation, my dear students. And presently, I can't count exactly, but closely I've taught around 10,000 plus students till date. Okay, so that is my, what do you say, my dream. That was my dream, to teach as many number of students as possible, and still going on with a great josh and energy here. Okay, so this is my fourth month on Unacademy platform, and here on YouTube Live, I'm very happy to present my lectures to each one of you who are the aspirants for Karnataka CET 2021 and many more entrance examinations after PUC second year or class 12th. Okay, so let us progress with our discussion. So, to begin with, let me just go ahead and tell you what Unacademy has to offer. Now, Unacademy is giving you an opportunity to go ahead and grab most of the benefits as a student, because Unacademy, no doubt, it has got a free platform. Now, on this free platform, with the courtesy of Unacademy itself, now you are watching this YouTube live session as well. Okay, even on Unacademy app, you have special classes, right? So those are absolutely free, my dear friends. But apart from that, you will feel like I need to do something. I need to have something more for my preparation. Then obviously the answer to that is your plus subscription. Now go ahead and grab this plus subscription, dear students, and you can very easily say that I can say that you will never regret that by taking a plus subscription. Okay, so what exactly is plus subscription? Plus subscription, it is the subscription for meant for Karnataka CET 2021 aspirants, and here, as the name itself says that it is plus, so plus means addition. So obviously, in addition to your free classes, you can watch some live premier classes. Okay, and for those classes you have to pay some premium. That's all, right? And I am also a plus faculty on an academic platform, and let me tell you, my dear friends, the lectures what have been delivered on plus platform, the material that is given to you is definitely out of the reach for any common student. So I can promise you that you will definitely get very good opportunity by taking a plus subscription for KCET 2021. Now, we have firstly, to begin with, a 12-month plan which I would propose, and this 12-month plan, it would cost 12,375 rupees. Okay, and it would cost around 1031 rupee per month. Okay, then we have a 6-month plan, and the 6-month plan, my dear friends, this will cost 10,125 rupees with an EMI facility. Suppose you want to avail, then 1,688 rupee per month would be your EMI. So you can choose wisely, think wisely, and get plus subscription. Suppose you want to try it, okay, then go ahead with our trial plan, 1 month plan. Go ahead with that. So 1 month trial plan, that would cost you 2,250 rupees. Okay, this is for new subscribers only. Okay, only one time you can take 1 month plan, not every time. Okay, so that is what for new subscriber means. Okay, then what you will be getting out of it. Now, why do you want to have plus subscription? First of all, if you want premium content at a very much affordable price, then you can go with plus subscription. If you want to have a structured live course, dedicated live doubt clarification sessions, you are a lover of that, then go with plus subscription. If you are looking for quizzes, because suppose you are a geek of quizzes, you want to test yourself time and again, then if you want quizzes, then go ahead with plus subscription, because we conduct quizzes at regular intervals. Okay, then there are batches for complete preparation. So not like one subject you are taking and only one subject you will get throughout. No, not like that. You will be getting the batches for complete preparation. That means all 4 subjects or all 3 subjects, like physics, chemistry, mathematics, or physics, chemistry, mathematics, and biology. Okay, and remind you, for these subjects put together, all these subjects put together, you are paying this much. Imagine, look at the cost, right? Then batches are there for complete preparation, as I was mentioning to you. So this is that description. Then you have test series containing daily practice papers, my dear friends. Daily practice papers. So daily you can go ahead and practice innumerable number of times. You can go ahead and practice. Okay, and that too, it comes with analysis. Again, full length mock papers. Again with analysis you will get. So this is the advantage. See, the moment you press submit in your DPP or full length mock, immediately your analysis will come. So how many questions you have answered correctly, how many questions you have answered wrongly, which is your strong area, which is your weak area, where you need to improve, all those things will come in the analysis. So definitely this is that analysis what you as a NEET aspirant, JEE aspirant, or CET aspirant would look for, is it not? Then we have, I can, all in all I can say, if you are getting all these things, what else you want? Okay, so I can say one single subscription, you will have unlimited access. So this is advantage Unacademy, my dear friends. And look at the costing, look at that, it is quite economic. So you can go ahead and plan this right now. Okay, so let us see what you will get out of it. You will be getting comprehensive batch, which is live. Okay, and you will have for complete syllabus preparation, as I was explaining to you, for complete syllabus preparation you will have this, right? Then you want to get some discount, okay, say some 10% discount. I think that would be great, right? When you are purchasing plus subscription, if you are getting 10% discount, then how can I get that? Use this code Uttam Live here, UTTAMLIVE, as your referral code while you are purchasing plus subscription. Okay, then I can say that you can avail a straightforward 10% discount. This is advantage on Academy again. Okay, so this is what I mean with reference to Unacademy Plus subscription, my dear friends. Now, chalo, let's make a move to our discussion for the day. Okay. Now, first question. A particle is acted upon by a force of constant magnitude which is always perpendicular to the velocity of the particle. The motion of the particle takes place in a plane. It follows that. Okay. Now, when a force of constant magnitude which is perpendicular to the velocity of the particle acts on a particle, okay, then work done will be equal to 0. Is it not? Right? Because we know that work done is F S cos theta and theta is 90 degree here. So work done will be Fs cos 90 degree, that is 0, my dear friends. Right? Then from work energy principle we can say that work done is equal to change in kinetic energy, and change in kinetic energy will be 0 here because work done is 0, right? So hence change in kinetic energy is 0. That is the answer that we are looking for. So therefore kinetic energy is constant, right? Because if kinetic energy is constant, then only change in kinetic energy is 0, is it not? Right? So this is the answer that we are looking for. Right, so let's progress to the next question now. A force F is equal to 5 I cap plus 3 J cap plus 2 K cap Newton is applied over a particle which displaces it from its origin to the point R is equal to 2 I cap minus J cap meter. The work done on the particle in joules is here. Now we will go with dot product. W is equal to F dot R, right? So over here, F is what? 5 I cap plus 3 J cap plus 2 K cap. That is F, vector F. And vector R is what? 2 I cap minus J cap. So clearly I can say that what is vector A dot vector B formula? Vector A dot vector B is AX BX plus AY BY plus AZ BZ. So obviously it is the sum of the products of individual rectangular components, that is dot product, is it not? So hence I'll take 5 into 2, 10, then 3 into minus 1, that is minus 3, 10 minus 3 is 7, 2 into, there is no k cap here, 2 multiplied by 0 is 0, so hence we'll get it as 10 minus 3, that is 7 joule. That is the work done, my dear friends. Okay, now let us progress to third question now. A ball is released from the top of a tower. The ratio of work done by force of gravity in first, second and third second of the motion. Okay, so very beautiful problem it is. See here, when ball is released from the top of the tower, ratio of distances covered by the ball in first, second and third second, we can calculate it as h1 is to h2 is to h3. That is 1 is to 3 is to 5, because we know from the formula hn is equal to u plus a by 2 into 2n minus 1. Now over here initial velocity is 0. So therefore I'll say that hn is equal to a by 2 into 2n minus 1. So hence hn is directly proportional to 2n minus 1 here, and n is equal to what we have. First, second, n equal to 1. So 2 ones are 2, 2 minus 1, 1. So we are getting 1 here. Then n equal to 2 I will take. Second, okay, n equal to 2, 2 2s are 4, 4 minus 1, 3, then n equal to 3 you put, then 2 into 3, 6, 6 minus 1, 5, so 1 is to 3 is to 5, that is the ratio, is it not? Okay, so I hope I'm clear on this part. Therefore let us write work done ratio now. Ratio of work done will be equal to, multiply simply mg on all three sides. Mg h1 plus is to mg h2 is to mg h3. Then this is work done. Potential energy is nothing but what work done, no? So obviously it is 1 is to 3 is to 5 again. Right? Okay. So That is the answer that we are looking for. So this is the ratio of work done, my dear friends. Okay, now let us go to fourth question now. A rifle bullet loses 1/20th of its velocity passing through a plank. The least number of such planks required just to stop the bullet is. I was telling you in the beginning that this session will have a very interesting problem like bullet and a block, and this is the problem I was talking about, my dear friends. So here we should find the least number of such planks required just to stop the bullet, because through one plank it will lose its velocity by 1/20th time. 1 by 20 times it loses. So hence, how many planks are required? Is not given anything other than this, right? So let us go ahead and crack this problem now. So we can say this is the plank. Okay, so through one plank, let me consider the distance as s here. Okay, so through one plank, when the bullet passes, its final velocity will be 19 divided by 20 u. Okay, initial velocity is u here, then 1 by 20 of its velocity is lost. So that means u minus u by 20. Will it not be 19 by 20 u? So this is with reference to one plank. Okay. So that I am considering. Now I'll consider thickness of the plank as a s here. So accordingly, if bullet enters with velocity u, then it leaves with velocity of u minus u by 20, that is 19 by 20 times of u. Okay. Then from the expression v square is equal to u square minus 2as, because this is retardation, so hence I am writing minus sign here. Okay. So thus I can write 19 by 20 u whole square is equal to u square minus 2as. Okay, then u square by 2as will be equal to 400 by 39 here. Okay, so what I suggest is you take 19 by 20 whole square, then you shift it on this side, on right hand side, shift it on right hand side, then 2as you take on left hand side, then we can see that we'll get 2as is equal to u square minus 3 361 by 400, right? So hence 400 minus 361 is 39 here. So 400 by 39, that will be what, u square by 2as here. Okay, followed it. Now after this, picture abhi baki hai, it's not over yet. Okay, now we'll consider n number of such planks, and here final velocity will be 0 after coming out of this plank, and each plank has thickness of s. Then for n number of planks, what will be the thickness? Ns, is it not? So hence I'll consider it to be ns. So if n planks are arranged just to stop the bullet, then again we will make use of v square is equal to u square minus 2as. Now remember, what is the final velocity here? Final velocity is 0 here, is it not? 0 is equal to u square minus 2a into ns here, right? So therefore n becomes equal to u square by 2as. Now what is u square by 2as? U square by 2as, from my previous calculation we have found that it is 400 by 39, is it not? So hence I can comfortably take 39 as approximately around 40. So 400 by 40 is how much? 10. So 10, but since I have increased the value, so I should consider a higher number here. So about 10, what number we have in the option? 11. So hence I'll pick 11 as my answer here. Okay, because I hope you understood here. For 39, what I did, I converted it into 40. I raised it by 1, right? So hence I can comfortably say that I should consider a higher number of this ratio. So higher number would be 11. So hence I, so like if I am in your place in the exam, I will think like this. Okay, so I will not pick 10, because in the option they have given 10 also. Please be very careful. Okay. So here, since 39 is rounded off to 40, so hence I'll take a number above the ratio what I'll get. Okay. So that is the trick that I'm adapting here. Now let's progress to question number 5 quickly, my dear friends. A cord is used to lower vertically a block of mass capital M by a distance d with constant downward acceleration g by 4. Work done by the cord on the block is, okay. Now in this particular situation, this is the condition. So here the block is moving down, and with the help of cord the block is moved down. So cord will have a tension T here, and if the block is moving with the distance d here, okay, if it is moved by distance d in the downward direction, okay, like this, then when the block moves vertically downward with acceleration of g by 4, then tension in the cord would be T is equal to m into g minus g by 4. Is it not? Relative acceleration I am taking. So hence m into g minus g by 4, that is 3 by 4 mg here. Right? So therefore work done by the cord is vector f dot vector s. So that is fs cos theta. Right? So therefore F is what? T. S is what? D. So I'll substitute that T into D. What is the angle between T and D here? 180 degree, because they one is upper, second is niche. So obviously we will say that upward and downward. That means angle is 180 degrees. So hence TD cos 180 degree. So therefore now what is TD cos 180 degree? Now T is 3 mg by 4. Okay. D is minus D here. So thus I'll get this as 3 by 4 mgd. Okay. So that is the work done. Work done minus 3 by 4 mgd. Now hope you understood why did I write minus here, because D is downward. So hence I am mentioning minus D. Okay. Now let us progress to question number 6 quickly. A spring of force constant 800 Newton meter has an extension of 5 centimeter. The work done in extending it from 5 centimeter to 15 centimeter is, okay. This problem is a cakewalk, is it not? W is equal to half k into x2 square minus x1 square. That is work done is equal to change in elastic potential energy, right? So half k into x2 square minus x1 square, and here as you can notice k is 800 and x2 is 15, x1 is 5, so hence I'll write it as 1 by 2 into 800 into 15 square minus 5 square into 10 raised to minus 4, because 15 and 5 both of them are given in centimeters, so I have converted them into meter. So centimeter to meter would be 10 raised to minus 2. Its square will become what? 10 raised to minus 4. That I have mentioned here. Okay. Then from this I can comfortably see that it is 8 joule, because 15 square 225 minus 5 square 25. So we will get this as a 200. 200 into 800. 2 8s are 16. 16, and there are 4 zeros. These 4 zeros will get compensated with 10 raised to minus 4. So 16 by 2, that should give me 8 joule. Okay. So 8 joule is the amount of work. Seventh question now. A mass of 0.5 kg moving with a speed of 1.5 meter per second on a horizontal smooth surface collides with a nearly weightless spring of force constant K is equal to 50 Newton per meter. Okay, the maximum compression of the spring would be, see here, very beautiful problem it is. Now, kinetic energy of mass is converted into potential energy of a spring, is it not? When mass falls on the spring, what happens here? The kinetic energy of that mass will be converted into potential energy of the spring, because spring will get compressed, will get hit. So that is what conservation situation here, right? So then half mv square becomes equal to half kx square from this I can comfortably write, is it not? So after that, therefore x becomes equal to what? So this half and half you remove off, then we can see that x is equal to square root of mv square upon k. Okay, thus let us substitute the values. Mass is 0.5 and v is how much? 1.5. So 1.5 square, I'm writing that. Okay, then divided by spring constant is 50. So I can comfortably say that the value is 0.15. Is it not? Okay, so this is 0.15 meter. Okay, I hope you understood why it is 0.15. So see here, 0.5 ones are 0.5 hundreds are. That will be what? 50. 0.5 into 100 is 50, no? So hence 1.5 square divided by 10 square. Under the root, when they come out of the root, what you will have? 1.5 divided by 10. 1.5 divided by 10 is how much? 0.15. Is it not? Yes. Okay. So now this is the problem that we have solved now. Let us talk about sixth problem now. The potential energy between two atoms in a molecule is given by U of x is equal to A by x raised to 12 minus B by x raised to 6, where A and B are positive constants and x is the distance between the atoms. The atom in stable equilibrium, atom if it is in stable equilibrium, then under what condition it will be? That is what they are asking. Okay, so hence now condition for stable equilibrium is always f is equal to minus du by dx is equal to 0. Okay, so that is the condition for stable equilibrium. So net force should be equal to 0. Okay, so thus here u is given, no? So minus of d by dx of a by x raised to 12 minus b by x raised to 6 is equal to 0. Okay, so thus I can write this as minus 12 a x cube x raised to minus 13 plus 6 b x raised to minus 7 is equal to 0. So therefore I'll get this as 12a by x raised to 13 is equal to 6b by x raised to 7. So therefore 2b upon a is equal to x raised to 6 here. So therefore finally x becomes equal to what? Sixth root of 2a by b, is it not? Sixth root of 2a by b is the condition that we are looking for, my dear friends. So this is the answer. Note it down. Okay, so this is the answer that we are looking for. Okay, now ninth question, a cakewalk question, very easy question. Which one of the following is not a conservative force? Very simple it is. Frictional force, nothing other than that, right? So force of friction is non-conservative always. Okay, now 10th question, the bob of a simple pendulum having mass small m and length L dropped from a horizontal position strikes a block of the same mass elastically placed on a horizontal frictionless table. The kinetic energy of the block will be, okay, very simple one. Now this is the situation. Now this block is left, this bob is left like this. Okay, from A to B travels, it hits the block. Okay, now potential energy of the bob at point A is what? mgl, is it not? Then this amount of energy will be converted into what? Kinetic energy. Okay, so therefore kinetic energy of the bob at point B will be equal to what? mgl, is it not? Hmm? Thus, as the collision between bob and block is given as elastic, so after collision bob will come to rest. Thus, due to total kinetic energy will be transferred to the block. So, kinetic energy of the block will become equal to what? mgl again. Okay. So, this is the answer that we are looking for. Is it not, my dear friends? So, our answer is option C here. Okay. So, with this note, dear students, I'm about to close this session. Okay, so this half an hour session we were able to solve 10 beautiful problems on work, energy and power, and in my next session, that is on 23rd, I'll be teaching you few more problems on this particular chapter. Okay, so until then, stay safe, be safe, sit tight, expect my session to come. Okay, thank you one and all, have a wonderful time ahead. I would like to say bye bye, see you.